late. Fine. Adya, Mariana, DST got it. Lemula. Fine, students. What about this construction? At least you will remember construction to construct 60 degree, 120, 30, 45. Okay. If you'll know that, along with that, you'll just have two concepts here. If you know the definition, loci or locus, students. Some call loci, some call loci. I'll teach, Mariana. I'll teach that later. Not all the questions are important here. Only what is required, I'll teach you all. Today and Sunday, even Sunday will complete. Monday will start circles. Then construction next week. Okay, we'll start with this today. Yes. All of you online, can you see the screen? Shall we start? Locus? Yeah. Locus is a plural word. Plural. Singular is loci. Okay, you can call it as loci or loci, students, anything. Okay, some call it as loci, some call it as loci. So you call however you all want. This is singular. Loci is singular word. Locus is plural word. Plural. When lot of locus, loci put together, we call it as locus. Next. What is the meaning of locus? Locus is a point and path. Look here. Sorry, this is singular, students. This is singular. This is singular. It is given here. The plural of locus. What is the plural of locus? Can you see loci is given? Loci. This is plural. When many locus put together, that is plural. So locus is a singular word. Mostly we deal with locus, singular value. Okay, what is locus? Locus is the path traced by a moving point which moves according to some given parametric. What is this? Geometrical condition. And anyways, you want to understand that locus is a path traced out by a moving point. So all these days we studied construction. If you want to construct a circle, you keep a point. From this point to this point, we have 2 points, students. 2 points. I join this line. This line I join. Let me say 5 centimeters. 5 centimeters. Okay, there are 2 points. Point 1 and point 2. Now what I do in protractor compass, I take this distance. Can you see 2 points distance I've taken in a compass? Right? I've taken in a compass. Then this distance, I'll just connect this point. Look here, I'll just connect this from one point to another point I've connected. I'll highlight the point, red one and even here, red one. So these are the 2 points and this is a line. Now, using this point, if I construct a circle, look here, if I construct a circle, this circle circumference is known as the locus or the tracing point. This is known as locus, tracing point. See, I've completed a circle. Fine. Using 2 points, I've completed a circle. Okay. So first I took point A, students. Point A. Next point B. Now this distance. Now if I keep another point on the same circumference, if I keep another point, I'll show you. This is point A and this is point B. Now I drew a circle. The same distance. If I take a same distance and I draw another line here, will this value increase or decrease? What do you call this? Will the value increase or decrease? See, if I draw a line here, what do you call this? This is a radius. What about the other line? Even this is a radius. What about this one? All this? All this are radius, right? All these are radius value, students. In the same way, point B. From point B, I draw a line. See, dotted lines like this. This is creating a path. Okay, this one is creating a path. Like this. Which means a point, initially just a point and a line A and B. That if you want to draw a circle, it has created a point, traceable point according to geometrical, that is what they have given here, according to geometrical condition. The geometrical condition is the length between 2 points is 5 centimeters. This is the condition given. This is the geometrical condition. The condition is the distance between 2 points is 5 centimeters. And we need to draw a circle. Draw a circle. This is the condition, students. And the path, this dotted line, is known as locus. Okay, these two lines follow this condition. 5 centimeters. It has to be drawn in a circular path. So this green line is known as locus. Locus is not only for circle, even for a straight line. Look, even for a straight line, the traceable path we call it as locus. Now I'll keep a point here, P. I want to move this 5 centimeters forward. If I want to move this point 5 centimeters forward, this point will get replaced like this, 5 centimeters forward. Main point, forward direction. Then 5 centimeters, same point, 3 centimeters backward like this, 3 centimeters. Okay. This path traveled is known as locus. This path is known as locus, P. From your left hand side, it has moved 3 centimeters. Right hand side, it has moved 5 centimeters. So those are known as conditions, geometrical conditions given. Conditions are limits given for us. 5 centimeters forward, 3 centimeters backward. This is known as locus. Locus is not only for a straight line, circle. Even for a straight line, we call it locus. Then one more, next. a point A and the locus here 5 centimeters. This is point P. This is a locus, students. A traced line, a point with some distance covered. This locus, and I draw another 2 points here, 2 points B and C. Okay, so this line AP will be equidistant. The point P will be equidistant by, it will be equidistance from B to C. So the distance of BP, if it is 5 centimeter, P to C also will be 5 centimeter. Okay, now I'll connect these two lines. AC AP will be equal to AC. Fine, which means this locus AP, students, this locus AP, a point with a line, this is a locus. If it is traveling towards left hand side, it becomes AB, and the same locus, if it is traveling towards the right hand side, it becomes AC. So the concept here, this locus AP, whatever distance it has traveled on the left hand side, say angle 30 degrees, even on the right hand side, same 30 degrees. This is the first theorem. Okay, it would have covered the same 30 degrees. Therefore, the distance between BP, if it is 5 centimeter, PC also will be 5 centimeter. Actually, all this is not required. This is not required. Construction is important. Okay, for just for definition purpose, all of you understood what is locus? Locus definition. It is just a point or a path traveled, students. It is just a point or a path traveled. That's it. Okay, that is locus. Now, if I construct a line AB, in this you need to remember two things: angle bisector and perpendicular bisector. Angle bisector. Next, perpendicular bisector. Perpendicular bisector. What do you mean by the word bisector, students? What is bisector meaning? You have to split into two parts. Very good. Angle. What are we bisecting here? We need to bisect angle. Next, perpendicular bisector. What do you mean by perpendicular, students? Perpendicular meaning is 90 degrees. So this line AB, if you want to draw a perpendicular bisector of this line, that is, a line should pass through AB. It should be straight and it should cut equally. I'll teach you how to draw this line. This is the most important part you should learn. Perpendicular bisector. Whenever AB is given, whenever a line AB is given, how to draw a perpendicular bisector CD. You can't take randomly, you can't take a value and draw in the scale. This is 90 degrees. Okay, this is 90 degree. For example, if AB is 10 centimeters, students, total value of AB is 10 centimeter. We need to draw perpendicular bisector. Perpendicular meaning is 90 degree. You should draw a straight line. It shouldn't be slanting like this. If it is slanting, the angle is not formed at 90 degrees. Okay, angle is not formed at 90 degree. It should be straight. If the total value is 10 centimeter, this point I'll name it as O. What will be the distance between AO, students? 5. And the distance between OB should be 5. Perpendicular bisector. So when AB is 10 centimeter, you can't use your scale and take 5 centimeter and draw a line. Okay, that is using scale. You're not supposed to do like this. I'll teach you how to draw angle bisector. Look here. Take 10 centimeters line. Or let me take 8 centimeters line. Fine. In 8 centimeters, if you want to draw angle bisector, this distance should be more than half. It should not be 4. It should be more than half. You don't have to measure. Just randomly take more than half. Is it more than half? Does it seem to be more than half the length? All of you respond. Okay. Now, from point more than half, students. Just randomly take more than half of this line. Top constant. Bisect meaning is two parts. Remember this concept. Bisect is two part. So bi meaning is two, which means we are making use of these 2 points, A and B. And we are creating two lines. I mean, Two cuts, students. Cuts or intersection. Two cuts or intersection. Everything is two. Okay, two bisector. So one line from this point, one line from here. This is first cut. I mean first point. Okay, second point, bottom. From the same point down another cut like this. Bisect. So first bisector is done. This is the second one. So total two like this. We are bisecting. Is this clear? Did you understand the way I've drawn? Yeah, that's it. Locus is all about this, students. Major topic is angle bisector, perpendicular bisector. If you know how to cut the angles, you'll be able to solve. Next, join this line. Along with this, you should know 120 degree, 30 degree, 50 degree. Let me join this line. Okay, what is the total length we took? What was the total length? 8 centimeters. If 8, what is half of 8, students? Where should this line pass? All of you respond. 4. Can you check the answer? Is it correct? All of you respond. Is it exactly at 4? Even without using scale, we got the answer right. This is not an angle bisector. Let me tell you how to name it. Name this as A, here B, angle bisector 90 degrees, and just draw two lines like this. Two lines. Now, according to similarity, we don't need to go much deeper into similarity concept, but according to similarity, if I join this line and this line, according to congruency, these two values will be equal, students. I'll name it as C, AC. Look here, let me measure AC and BC will be equal. If I measure AC, what is the value? All of you will read. What's the value given? 5 point? 5.5. According to similarity or congruency, even the other side also should be equal. According to congruency, isn't it 5.5? It should be the same, student. It will definitely be the same. 5.5. Is this clear? If both are 5, what kind of triangle is formed? Very good. Isosceles triangle. Isosceles triangle. Right? Now, which one is the locus here? Which is the traceable path, students? Which one did we take reference? Look here. AD. Yes. Look, I have placed this AD. AD is the traceable path. The blue line is the traceable path. Let me place it little top like this. Okay, AD is the traceable path, students. Traceable path, that is the locus. AD is the locus. Now, from there, if you turn, from there, this blue line is turned towards CA. So even the angle also will be same angle. Look, let us measure the angles. So I need to keep it like this. Even the angles also will be same. Okay, can you tell me the angle formed here? Total how many angles? No, let me keep it like this. 0 degrees. 0. What's the angle, students? What's the angle formed? Isn't it 45? Can you see 45 here? 45? Okay, the same if I measure it here, even this also will be 45 from this part. What is the angle formed? Isn't it 45? 0, 0, like this, from here to here. Can you see the answer here? What is given? Isn't it 45 degrees? 45. Okay, which means even the angles are also same, student. The angle. So in angle bisector angles, let me explain here. I taught you how to draw perpendicular bisector. You take AB. If it is 10 centimeter, more than half, take more than half, cut an arc. From B, cut an arc. Then again, bottom, cut an arc. Cut. bisect this angle. This is known as angle bisector. The values will be 5 centimeter, 5 centimeter. First point. You will get two triangles here. The length will be same, students. It's isosceles triangle. And even this angle also will be same. We got it as 45 degree, 45 degree. Okay, 45 degree, 45 degree. This is the concept. Fine. According then related, that is what they have explained here. This is the first rule. The locus of a point. They won't ask this. Just ignore. Can you see we got the same diagram? All of you will respond. Did we get the same diagram? P lies on the perpendicular bisector. Look here, perpendicular bisector of AB, which means P is the perpendicular bisector. And I taught you how to get this P, students. From B, you cut a line. From A, you cut a line, you'll get P. And from B down, from A down, this line will extend. Using the same concept, they've drawn this triangle. It's a right angle triangle. First theorem. Or just ignore it. Second theorem. Even this theorem is not required. Theorem, they don't ask much. This is what I taught you all. Perpendicular bisector. Okay, perpendicular bisector for how many lines I taught you all, students? Only for one line, right? One line. Now second construction. It is given in a textbook. If you want, you go through. If not, I'll teach. Look here. The locus of a point is equidistance. Which is the locus, students? Which is the dotted line here? A, B, C or BL? Which is the dotted line? Respond. BL. BL is the locus here. Yeah, BL is the locus. So from locus, the other two angles, the other two of a point, equidistance from two intersecting lines. What are the two intersecting lines we have? AB and, yes, AB and BC. Okay, AB and BC is the bisector of ABC. So for this triangle ABC, which is in between, students? Which term is in between? Which variable? B is in between. B is the angle bisector. So first one what I taught was perpendicular bisector. Second I'll teach you construction of angle bisector. Angle B is formed. Okay, now I'll teach you how to construct this angle bisector. Okay, in order to draw angle bisector, first we need to know the angle, students. Angle of B. If it is 60 degree, can you all respond? If it is 60 degree, what will be half of it? On both the sides, it should be 30 degree and 30. Okay, if I take 90 degrees, then 45 each. See, if you want to draw angle bisector, what will be the value? 45 and 45. Locus is all about construction in the reverse way, students. They won't give this middle line. This dotted line we should draw. I'll name it as BP, locus. They'll just give ABC. Fine. Here no angle is given. Look, in this question, they didn't mention. Have they mentioned angle of ABC? Whatever angle they've taken, have they mentioned here? No, right? This is just for reference. They didn't mention, but we'll assume a value. Let us take 90 degrees. 80% is related to construction, only 20% extra topic. Okay, let us draw 90 degrees, students. All of you know how to construct 90 degrees line, right? 90 degrees. Okay, let me take the base. Let me take the base as 5 centimeters. Now, how do you construct 90, students? All of you will respond. Yeah, even here, not more than half. When you're drawing arc, this is normal construction. It should be 2 centimeters, 2 or 2.5 centimeters. Then what do? You cut an arc, right? Yeah, we cut an arc like this. The arc is too big, cut it small. Then for 90 degree lies in between which two values, students? 60 and, yeah, 60 and 120. So first draw 60 degrees here, 60. This is 60 degree. Then from 60, you have to draw 120. Then from 120, even this is known as angle bisector, students. Look here. We have drawn 60. Then from 60 to, look, to draw 90°, I'm taking the value of two lines here, two dots. Even this is also, we are drawing 90° with respect to angle bisector concept. Look here, 90°. This is 90° line. 90 degrees. Now, we need to draw angle bisector. That is a line between these two. I'll name this as A, I'll name this as B and C. Right? Now, this is the right angle triangle, ABC. If you want to draw angle bisector, AB, what is mentioned here, students? Angle bisector lies in between which two points? AB and BC. AB, BC. For both of these, which letter is common? Which alphabet is common? Angle B is common. So take angle B. From angle B, draw a random arc like this. Cut a random arc. Then from this point, look at point P. From this point, more than half. I told you all more than half. Just cut an arc from this point like this. Then again from here, from point Q. From point Q, cut an arc. Okay, so choose the alphabet which is present twice, students. B is present. From there, draw an arc. Next, AB. From A and B, whichever point touches in the line A and B, the point, and P and Q. Cut another arc. This line will be the angle bisector. It will definitely be 45 degrees and 45 degrees. Okay, when it comes to construction, do we already have that arc here? Do you already have an arc here? All of you will respond. Okay, then take some random value, students. Look here, I'm going to take a random value. Can you see where I have placed the protractor? From there, cut an arc like this. Look. So 90° is done. Now I'm going to draw the angle bisector, 90° from here and from this point. Look where I've kept the point. Cut an arc. This is angle bisector. Now if I join this line, this line is known as angle bisector. And if you measure, it should be 45 degrees. Is this 90° triangle? Can you see that red line? Where is it passing, students? All of you will respond. Where is it passing? 90°? Understood the difference between perpendicular bisector and angle bisector? That's it. Today only basics I'll teach. We'll solve one or two questions and Sunday we'll complete this. Fine. Now all of you will respond. Yeah, tell me, Naomi. Yeah, tell me. Fine, Mariana, go through the recording. Okay, later. Tonight complete it or on Sunday you complete. Yes, you can leave. You can leave. Others, all of you understood? Now imagine we construct another triangle ABC, students. ABC, I'll take it as 60° here. 60°. Next, for angle bisector, take the same arc, this point and this point. Take some random value, cut an arc like this. And from B, from point P and Q. From P, cut an arc. From Q, cut an arc. You'll get a line. Can you tell me the value of this line? What will be the value of both the angles? It should be 30 degrees. 30. This is angle bisector. So angle bisector is this. Perpendicular bisector, they'll give you just one line, AB. So from A, take more than half, cut an arc. Top and down. We need a straight line. This is perpendicular bisector. And both these concepts are important for construction point of view. We need circumcircle, incircle. There are a lot of topics. So this is perpendicular bisector, 5 centimeter, 5 centimeter, half and half. Shall we start solving the questions? All of you understood the difference? Okay, what about Joanna, Lemula? Is it clear, students? Fine. See, first question. The locus is just a point with the tracing path, students. It's just a point with the tracing path. The first type of question, they will never ask such questions in board exam. Just for you all to practice. We will just solve 3 or 4 questions from the first main. Describe and construct each of the following loci. The locus of the tip of a minute hand of a watch. So basically what you do is draw a circle, students. You need to draw a circle. You all don't have to do this, just listen, I'll do it. First thing, you need to draw a circle. Once you draw a circle, keep a center. Keep a center, and from there you have to draw tip of the minute hand. You all know what a minute hand is, right? Minute hands and hours hand. Just randomly draw some minute hand like this. This is loci. Now what is the time, students? According to time, this is 12, 3, 6, 9. Okay, let me place it here. You'll have an idea. You need to draw the locus here. This point P is O. From here I've drawn the minute hand here. Minute hand. You can just put an arrow. This point and this entire red line, this entire thing is known as locus. Is this concept clear? Do you understand this? Using a protractor, you'll draw a circle. This is locus. Now, according to locus concept, even if it goes to 12, do you think the minute hand will change? The length and breadth length will change? Do you think the length will change? All of you will respond. In your wall clock, students, in your wall clock, do you think the length of this one will change? No. And what do you call these lines in terms of circle? What do you call them? From one point to the circumference, whatever touches, you call it as radius. Even when it goes to 6 o'clock. Now the time is 6:46. Minute hand is 6:46. Even if it goes to 6 o'clock, the length of this locus will not change. Locus is in this wall clock. In practical situation, the minute hand of the wall clock is known as locus. Okay, minute of the wall clock. The concept of locus is wherever it goes, the value will not change, students. Value will not change. The same locus, if it goes to 3 o'clock, the distance will not change. It will remain the same. Fine. So the answer is just draw a circle and 1 minute hand. If you want, you can name 1, 2, 3, 4 up to 12 of a watch. Okay. Or just randomly write 12, 3, 6, 9. Just 4 and keep a point. Just point towards this. This is the answer. So all these are practical examples of locus. Okay, second concept. Second, the locus of the tip of a pendulum of a clock. Have you all seen pendulum in physics? Did you all do the experiment, pendulum experiment? A string, students. What is pendulum? Basically, a pendulum is a string and you have a ball of or some kind of attached to it, right? Attached to this. Yeah, this is pendulum. This entire thing is known as locus. Locus. And this path, students, if I push it in this direction, see this locus. No, this is not locus. The path which this ball, this covers, that is locus. Look here. If I push it to the right hand side, you would have done an experiment in physics. This is a pendulum. If you push it, it goes here. B. And when you just push, it keeps moving like this. This is C. This traceable path is known as locus. It keeps moving, students. It keeps moving like this. And after a certain point, it comes to rest. I will done this experiment in physics in 10th standard. No? Okay, mostly 11th and 12th you all might have this, students. A pendulum. Okay, or just imagine a string with a ball. A string with a ball. If you just push it forward, it keeps rotating. It goes to the left hand side, back to right, again left, right, and at one point it stops. So that path, whatever path it is traveled, that is known as locus. Okay, now the same string. Think you are holding it, student. Some person is holding it. Okay, some person is holding the same string, upward direction, and is trying to rotate it. If he's trying to rotate it, this this pendulum will rotate in a circular direction like this. Can you just imagine if you're holding a pendulum and trying to rotate it? It will rotate in this direction, right? And the distance will not change, students. Distance will not change. So this is known as locus. It's a point or a path traveled by a certain object. A path traveled by a certain object. And what is the other thing you will have used? Just basically a path, student. A path. That's it. That is locus. Hmm. Next, the locus of a point 5 centimeter from a fixed point O. Take a point fixed point O, and what is the locus value, students? Locus of a point 5 centimeter from a fixed point. From here you take 5 centimeter. I showed you in the beginning 5 centimeter. Okay. From here construct a circle. If you construct, it goes in this part, this direction. This is known as locus. And all this value, students, from center to this point, this is first point A. If you take a random point B, even this will be 5 centimeter. From center you take another point C. You measure, it will have 5 centimeters. That is radius. Radius will not decrease. D. 5 centimeter, 5 centimeter. You take any point, it is 5 centimeter. This traceable, the pink line, the pink dotted lines, this is known as locus. So locus is just a path, and the geometrical, what was the definition given? Look here. A path traced by a moving point which moves according to some given geometrical condition. Fine. Here the point was 5, students, 5, A. Okay. The point was A and the geometrical condition is 5 centimeter from a fixed point. That is the geometrical condition given. So according to geometrical condition, the pink line is the locus, traced. It is the traced path, locus. Simple. They won't give all this. I mean, they won't ask, just for reference. Is this clear? Understood how to draw a diagram? Response, students. Do you have any doubts? Next, locus of a point equidistant from OA and OB. Okay, the locus of a point. We'll do another 1 or 2 question and we'll do the second and third one after break. Okay, take 7 minutes break. We'll continue at 7 p.m. Okay, all of you online. Respond. Shall we do the next one? Respond, students. See, this is what I showed an example. Locus of a point equidistant from two arms. I mean, from the arms OA and OB. So for OA and OB, which is common? Which point is common? Adya online, Adya, Diyashri, Joanna, Lemula. At the fifth question, first main fifth one, students. For OA and OB, which is common? O is common. Yeah, keep O here. And no angle. Angle is not given. Angle is not given. Take random angle. We'll take this as B and this as A, students. A. We'll construct 60 degrees. This is 60 degrees. How do you construct locus, which is equidistance? Equidistance is nothing but, for angle, what do you call, students? Angle bisector or perpendicular bisector? Angle bisector. This. From this point P, cut an arc. Then from this point Q, cut an arc. This is known as angle bisector, which means equidistance. The distance is equal. What do you mean by distance, students? If entire 60 degree is given, this is 30 degree and this is 30. So here they have just avoided the words angle bisector, triangle, rectangle, nothing. They'll just give you like this: arm OA and OB, equidistance. So it is understood whenever locus is given, draw a triangle. It should either be angle bisector or perpendicular bisector. Angle or perpendicular. Whenever angle is given, triangle is given, it should be angle bisector. When a straight line is given, it is perpendicular bisector. Enough. First main, they won't ask students. See, none of the questions they have mentioned here. Locus is very rare. See, 2009, I think 2014 or 15 was the last. Locus, you don't get much question. Even in this textbook, whatever they're given, 2009, we had a question, locus question. Okay. We'll solve one or two questions now. Second main. Look at second main. All of you will start solving the question, students. We'll do the third main. Draw a triangle BC. All of you will construct a triangle first. Which one you have to take base? 5.3, 4.8 or 4? 5.3. Why 5.3? Yes, greatest. Completed. First draw normal construction BC 5.3. Then from C, how many centimeters you have to take? 4.8 centimeters and an arc. And from AB students, from B you have to take 4 centimeters. You'll get a triangle like this, right? Triangle. Okay, first complete this triangle. Next, I'll tell you the second point I'll teach. Even here, the keyword is equidistant. Equidistant is angle bisector. And you'll have been doing this from 6th standard students. The only thing is you all didn't know what locus was. They didn't give you a definition. But from 6th, 7th standard, we are constructing triangle, angle bisector we have studied, perpendicular bisector. BC is 5.3 centimeters. AB, no, BC is 5.3 centimeters. AB is 4 centimeters. Only the baseline you should draw using a ruler. Baseline. The other two lines you should use compass, students. What is AB? AB is 4 centimeter. AC is 4.8 centimeter. Let me draw AB first. 4 centimeters. AB is 4 centimeter. AC is 4.8 centimeters. Take 4.8. All of you completed? Did you draw a circle? I mean, not circle. What is this? Triangle. It's a 3 marks or 4 marks student. They give it for 4 marks. For this, you'll get 3 marks, not 2 marks. And for equidistant, Joanna done, Diyashri, Joanna, Lemula, Naomi, triangle. Next. This is the most important part, students. What is given? Find the construction, find by construction a point. Find by constructing a point P, which is equidistance from which 2 points, students? Equidistance from, what is the common alphabet here? B. What are the keywords I told you all? Whenever you get equidistance, which chapter is this? Normal construction or locus? Respond. It is locus chapter. In locus, we need to find a point P. That will do it later. Find a point P which is equidistance from BC and AB. For BC and AB, which is the common value? Which is the common alphabet? B, right? Now B, students. Now what you'll do, we need to calculate angle bisector. So what did I tell you? Draw a normal arc like this. Cut an arc. See, I'm just cutting a small arc. It can be of any value, any random value like this. Then from here, cut another arc here like this. Because they've given B, I've targeted B, students. B. Cut an arc like this. This is known as angle bisector. This point is called angle bisector. Okay. Just join this line. Look, this blue line is the angle bisector. This is known as angle bisector, students. So whenever angle bisector is given, it is locus concept. Locus. And don't write it. Let us read the question again. What else is asked? P, construct a point P which is equidistant from B and C, also equidistant from B and C. Okay, also equidistant from B and C. Fine. In this line, where should I point? Plot P, students. See, this blue line is equidistant for which one? All of you respond. For BC and AB, and also equidistant from B and C. Let us construct that. Look here. And also equidistant from which 2 points? B and, yeah, I need to construct that. I need to construct. First, complete this. Complete this part. There are two equidistant points, students. Okay, first is done. All of you completed. Got a blue line. Okay, what you'll do, don't draw this blue line, draw a dotted line, students. Here it is difficult for me to draw a dotted line. Keep this dotted line. Next, look at first part is done and also equidistant. One more equidistant is given. Another word equidistance, one more locus concept from BC. Fine. What is given here? BC is a line or what? Is it one line or two line? BC. All of you respond. B to C, the single line or two line? No, no, single line. What about the first one? Whatever we did, students. BC and AB, are they single line or two line? Two lines. BC was one line and AB was another line. Whenever two line or two values like this is mentioned, is it angle bisector or perpendicular? This is angle bisector. But whenever single line is mentioned, what do we? Yes, this is known as perpendicular bisector. Now I'll teach you. I've already taught. We'll construct perpendicular bisector. When two lines are given or two angles are given like this, the common alphabet is B, students. B. So start the arc with B. That is what we did. We need to start the arc with B. Angle bisector is done. Next, we need to target BC for perpendicular bisector. What is the concept I told you all for perpendicular bisector? You have to take more than half, right? Can you see I've taken more than half? Just a random value, student. More than half. Okay, more than half. Now, let me use green line. What am I supposed to do with this line? Cut two arcs, top and down, right? From C, I have to cut how many arcs? Respond. All of you will respond. How many arcs should I cut? Two arcs? Yeah, two arcs up and down. Okay, you all cut an arc, student. There is some problem. Look, I cut two arcs. Then, which is the other point I have to take from B? It is done. Where should I place this again? I should place it on C. C, right? From C. Look, from C, I've cut another arc, the orange one, here and bottom, like this. All of you understood this line? Can you see this line, students? Respond. Can you see this line? Okay. Now connect these two lines. Look here, connect these two lines. If I connect these two lines, are they meeting at a common point here? Can you see a common point? This is point P, students. This is point P. This one is point P. Look, I'll show you later. You can do. Look at the screen, all of you. If you have understood 3 or 4 questions enough, you'll be able to solve other questions. Look, first thing, BC, students. Draw BC. Then we bisected A. We got a triangle like this. Then angle bisector. For angle bisector, B is the common point. From here, cut an arc. Okay, imagine the two arcs are like this. Draw a dotted line. Then on this top of this line, there should be P, right? What is the point given here? Read the question and tell me. Which point? Point P. So where can point P be, students? Have they given any centimeter? 5 centimeter, 3 centimeter? No. See, point P can be here. Point P can be here. It can be here. Anywhere. We don't know the point. Unless and until we need another line. That is known as perpendicular bisector. So for B and C, take more than half, cut an arc here. Top and down from C. Then from B, cut an arc. You'll get a straight line. This point P is the answer. This is point P. And we have two locus here. What are the two locus here? Both these dotted line are locuses. Both the dotted line are locuses. Okay, start the construction. This is how your diagram should look like. After construction, a diagram should be like this. So we had one angle bisector, one perpendicular bisector. Locus concept. Yeah, Joanna, at what time you have to leave? 7:18. You forgot, or you want to continue? Okay, complete this. Go through next 15-20 minutes recording and attend on Sunday, Joanna. You yes, you can do. Completed? Done? Response, students. I will got this kind of diagram. Any doubt? Any doubts between these two? Okay. You'll measure and tell me what is the distance between B and C, BP, students. Use a scale and check what's the value did you all get? All of you should have got the same value. Yes. Lemula done. Naomi, Lemula, Adya, Diyashri. Yeah, I'm asking you at this point. I got around 3 centimeters. What about you all? 2.93, 2.75. 2 point? Okay, 7, 2.8, close enough. Almost close enough. Bhargavi, it is 720. 7:25. Attend after 10 minutes. This is the answer. Anything is fine, students. 2.5, 2.9. I mean, 2.5 is very less. It should be 3, 3.1, 2.9, 2.8 is also fine. Next question. Next, one last question, and tomorrow, Sunday, we'll solve the previous year questions. A such that it is equidistant from another point, CD is 3 centimeter. Fine. They can give whatever questions they want, they can ask. Look here, AOB is 60 degrees. All of you will respond. What is the angle of O students? AOB is how many degrees? 60. O is in the between, middle. So this is 60 degree. Mark a point P, equidistance from two value. Is it a perpendicular bisector or angle bisector? When two values are given. Respond. All of you will respond. Why nobody is replying? P is equidistance from O and OB. When two lines are given, it is angle bisector, right? Yes. First draw triangle AOB. All of you will construct triangle AOB 60 degrees. Do you all know how to construct 60 degrees? What is given? AOB 60. Any value given? For OA and OB, any value given, students? You can take random value. Take 5 centimeter, 6 centimeter, anything is fine. So don't get confused. In construction, what about construction, students? They give us values, right? Yeah, in construction, they give values. Here you can take 5 or 6 centimeter. Take 6 centimeters and try. Take the base 6 centimeter. The base you can take it as OA. Take the base as OA, students. Draw 6 centimeter. Or take it as B. Take it as B 6 centimeters. Then 60 degree. Construct 60 degree. 60 degree lies in between 0 and 90. Sorry, one arc. For 60 degree, just one arc is enough. Like this. And you have to cut only one single arc like this. Okay, take 6 centimeter and draw A. Complete it till here. Be quick. This is 60 degrees. Last question, students. Done 60 degrees. Next, tell me the second part. Read the second part. What is given? Mark a point P equidistance from which two lines? OA and OB. Yes. So for OA and OB, when two lines are given, see this is the line, this is the line. Angle bisector. What is common to them? Which point is common? O is common. Very good. So from O, you have to cut an arc. Can you see already there's an arc here? Yeah, already there's an arc. So what you do? Look from here. Let me cut an arc, students. All of you will cut an arc from this point. Draw a random arc. Then from here to here. Draw a random arc like this. Look where I placed the protractor. It's an angle bisector, not perpendicular bisector, angle bisector. Then draw a dotted line. Don't draw a straight line, draw a dotted line, students. Very quick. Completed. All of you have drawn. Respond. Did you draw this dotted line? Next, mark a point P equidistant. So P should lie on this point, students. Have they given any centimeters? No, no. On this is have they given any centimeter? P is 3 centimeter, 2 centimeters. No, they haven't given anything. So P can lie anywhere, students. It can lie anywhere on this line. Okay, it can be here. P can be here. P can be here. This point, anywhere. We don't know where P lies, but they have given us one more clue. What is the other clue given? Such that its distance from another given line CD is how many centimeters? 3 centimeters. Okay, its another line is 3 centimeters. So what do you mean by that? You can take OB, students. From OB, how many centimeters? Such that distance from another line CD is 3 centimeters. If you take CD 3 centimeters, 3 centimeters. Mark a point P, equidistance. Okay, we got the line. Such that its distance from another given line CD is 3 centimeters. So that P should be 3 centimeters away. 3 centimeters in the sense. Okay, you can choose any one base. Shall we take OB? OB. So from OB draw a parallel line, students. From OB draw a line which is 3 centimeters. Cut it like this. Cut it like this. Look here. From OB, take scale. It should be 3 centimeters. Just a minute. 3 centimeters. See, it should be like this. 3. One minute. A minute. Such that its distance from another given line. This P is distance from another given line CD. Why CD is given? CD is 3 centimeters. Okay, this line, all the points are 3 centimeters. Fine, just skip this, students. For now, just skip. Only the first part you all complete. Sunday will continue with this. Okay, till here we have done. Fourth main. Did you understand the third question? Third main? Third main? Third question. In fourth question, we have done only the arc such that distance CD is 3 centimeters. From here, we will continue on Sunday. Okay, when I have little confusion in that. We'll continue on Sunday, students. I'll teach all fifth main, then we'll solve few previous year question. Fine. Tomorrow till what time you'll have? The entire day you'll have graduation. Tomorrow it's not possible. Sunday at what time? You know what? Will I conduct at 4 o'clock? 4 to 6? Attend at 4 o'clock on Sunday, students. Okay, you all can leave. Yes. This post, yeah, you all can leave, students. Attend at 4. And yes, bye. Bye.